In this example, we're going to construct a salt-bridge voltaic galvanic cell with graphite electrodes, acidified potassium permanganate solution, and a copper 1 nitrate solution. Potassium bromide is in the salt bridge. Everything that we're expected to demonstrate is on this list below. Let's get started and see if we can get this done in 5 minutes or less. Okay, so we have graphite electrodes. We know these are unreactive. So really what they're going to do is they're just going to provide a surface on which the reaction takes place. We have an acidified potassium permanganate solution. So if we have an acidified potassium permanganate solution, what we're going to do is it's acidified, we have potassium ions, and we have permanganate solution or permanganate ions. We also have a copper 1 nitrate solution. So we've got copper ions, nitrate ions, and in the salt bridge we have potassium bromide, which is a relatively unreactive substance, so we don't really need to include that. Okay, so let's go to our oxidation tables. We look for our SOA and our SRA, and we find that our SOA is going to be the acidified permanganate. These two together make up the SOA. Oh, I meant to also write that we do have water because these are solutions. I'm sure somebody's already caught that. And then we have over here the SRA as well. Okay, so this copper ion, because it's the SRA, it's going to give up its electrons to the SOA, which is going to take them. So what I'll do is I'll start with my oxidation reaction, and your oxidation reaction happens at the anode, and your anode is negative, and that's your graphite anode. And the oxidation reaction that's happening, your half-ox reaction, is going to be your copper ion giving up an electron to form copper 2 positive and an electron. All right. On the other side, we have our cathode, which again is made up of graphite. Cathode is positive, and we have our reduction reaction happening there. And that one's a little bit more lengthy, so I may have to do it over 2 lines, but it's your permanganate plus the acid, and it wants to gain 5 electrons to form your manganese ion and 4 waters. Okay, so this is giving up its electrons, this is taking electrons. Okay, so this right here, okay, electrons are flowing from here to the other side and onto this electrode. Now you'll see that this electrode is made up of carbon. It's not made up of copper ions. So where are these copper ions? The copper ions are in solution right here. Okay, and as I said before, the graphite anode is just providing a surface for the reaction to happen. So as the copper ions come into contact with the surface, they give up their electron, right? Travels through the wire to the other side, and then what comes off of this is your copper 2 ions. Okay, the other thing that is in this solution is nitrate. On this side over here, we have acid ions and permanganate. And when I say acid ions, I just mean protons or hydronium. They, again, will just come onto the surface of the graphite. So this electrode itself is not reacting. Okay? They come onto the surface, and what comes off of that is manganese ions. Okay. The other thing that comes off of this, as you can see right here, are water molecules. That also comes off of it. In the salt bridge, we had potassium bromide, so the potassium is here, the bromide is here. Anions move towards the anode to prevent too much of a positive charge from building up. So these anions are migrating to the anode. Okay. The cations are migrating to the cathode. So any positive cations are migrating to the cathode. So these ones are going to go all the way through and come on to the other side. Okay. All right, so I think I've sufficiently demonstrated what's happening in the cell. Now what I'm going to do is I'm going to do my half-ox reaction. Well, I had already written that above. That is copper ions. This time I'm going to include states. Going to form copper 2 positive, aqueous, plus an electron. I look at the E for that reaction, and that is negative 0.15 volts. Okay, note that you have to flip it because it is in fact an oxidation reaction, half reduction reaction. That's the longer one. That's going to be your permanganate ions with 8 protons, 5 electrons, forming manganese ions and 4 waters. And the voltage of that reaction is 1.51 volts. Okay, before I go ahead and do an overall reaction, I have to acknowledge the fact that this is only giving up 1 electron, and this needs to take 5 electrons. So what we do right here is we take this right here and we multiply by 5. Note that we don't multiply the voltage by 5 because voltage is joules per charge. So we're not increasing the amount of voltage per charge. What we're just doing is we're increasing the number of electrons that are flowing through. Okay, are flowing through to the other side because the other side needs to gain those 5. Okay, so I didn't quite make my 5-minute speed run, but what we'll do here is we'll just keep going and I'll still try and keep up the pace. Overall reaction here is going to be 5 copper ions, your permanganate ions, your 8 protons, going to form 5 copper 2 plus ions, your manganese ions, and your 4 waters. Okay, be mindful here. Now we're going to add these two to find the net voltage, or how much voltage this cell can produce, and it is 1.36 volts. All right, I want to do my cell notation, so I'll do that at the top. My cell notation is a solid carbon electrode submerged in acidified potassium permanganate. That's physically separated from a copper nitrate solution, copper 1 nitrate solution, and you have a graphite electrode there as well. Okay, last thing is my observations. Well, if we look at the solution around the anode here, we're having copper 1 ions become copper 2 ions. Okay, we go back to this right here. Copper 1 ions are green, copper 2 ions are blue. So around the anode, so solution around anode goes from green to blue. Okay, and then if we look at this right here, the solution, my permanganate ions are purple, but my manganese ions are pale pink. So there we go. Solution around cathode goes from purple to pale pink. Okay. I think the key thing here in this example is that both the anode and the cathode are not at all involved in the oxidation reduction reaction. It's the actual solutions that they're submerged in that are reacting. So the ions in the solution are undergoing oxidation and reduction. These just provide the surface on which the electrons can travel through and onto so that the reactions can in fact happen. All right, definitely didn't make my 5-minute speed run, but still not too bad.